Hello and welcome to Finance World. In today's video, we are going to continue with the topic of quadratic equations and finish completing the square. In the last video, we were left with the following quadratic equation, that is 2x squared plus 12x plus 6 is equal to 0. And this is where the quadratic coefficient is not equal to 1. So how do we solve this? First, we have to divide through the quadratic coefficient, and we will end up with x squared plus 6x plus 3 is equal to 0. Now we can proceed with completing the square. Okay, so notice that the linear coefficient is positive 6, which means we can rewrite this in the form of x plus 3 all squared. And then you've got to account for the positive 9 from squaring x plus 3. So we have to minus 9 from the whole equation there on the left, just to make sure we get back to the original x squared plus 6x plus 3. Now you can collect the constant terms, and if you proceed to solve this, you will end up with two values for x. Remember that when you square root a number, you have a positive square root and a negative square root of a number. Okay, let's revisit the fish and chips market stall problem. Okay, recall that when we had a demand function that related the quantity and price, it was Q is equal to 1000 minus 100p. Now, also recall revenue was the quantity of the units sold, that is Q, multiplied by the price that we set, which is 1000p minus 100p squared. Okay. And then we also assumed that a cost was £2 per portion, and we model the cost as the cost per portion multiplied by the demand function. And finally, let's not forget rent was £500 per day for 2 days. We then defined something called profit, which is the revenue minus the total cost. Okay, so revenue was 1000p minus 100p squared. The cost was 2 times the demand function of 1000 minus 100p, and also 2 days of rent, which was 1000. Now, let's multiply out the brackets and also collate the like terms together. We now end up with profit is equal to minus 100p squared plus 1200p minus 3000. Okay. In order to find the minimum price, we have to set profit equals to 0. That means that the revenue you earn at this price when we solve to find P, the revenue will cover the total cost. Okay, first we can divide through the equation by minus 100, and that will yield P squared minus 12P plus 30 is equal to 0. Obviously, by looking at it, factorization was quite hard to find two numbers that sum up to negative 12 and multiply together to get positive 30. So we go ahead with the complete the square method. First, notice that the linear coefficient of p is negative 12, so we halve that and we have minus 6. You add minus 6 to p, the variable you're looking for, and you square the whole of that. That means you can have p minus 6 all squared minus 36, which is the extra term from squaring p minus 6 all squared, plus 30 is equal to 0. Okay, what you then have is you solve it and you have p is 6 plus or minus the square root of 6. That implies that p is equal to £3.55 or £8.45. That means that your optimal price should be range bound between those two prices, because you've just solved the equation where your quadratic is equal to 0. That means any revenue that you earn by selling a portion of fish and chips at either £3.55 or £8.45 will just cover the cost. Okay, in order to find the optimal price, note that a quadratic function is actually symmetrical, and either the maximum or the minimum is found at the highest or the lowest point where the curve turns. Okay, and it's only a maximum and the highest point when you have a negative p squared function, and it'll be a minimum or a lowest point if it's a positive p squared function. In order to find that, This happens when you have p minus 6 all squared is equal to 0, and that's because 0 is the only number that does not have a positive version or a negative version of itself. 0 is just 0. That implies you only get one solution. Solving that yields p is equal to £6, and that price would generate you the maximum profit. Okay. This means that you can actually complete the square for any arbitrary quadratic equation. Now let's take ax squared plus bx plus c is equal to 0. And then first you can divide through by a, the quadratic coefficient, and you get x squared plus b divided by a times x plus c divided by a. Okay. We can actually complete the square with this. So the linear coefficient b divided by a, you halve it and then you add it to your variable x and you take that all squared. And don't forget to account for the constant term. So you end up with x plus a half of b divided by a all squared minus a half of b divided by a all squared. Well, that's the extra squared term you get for multiplying out the brackets, plus c divided by a. Note that all of this is just a constant, it's just numbers, there is no x involved in this, so you can move all of this to the right hand side of the equation. Thus, we just rewrite it as x plus b divided by 2a all squared is equal to b squared divided by 4a squared minus c divided by a. Note that you can actually multiply this final constant term by a 1. What do we mean by multiply by 1? Well, first we are going to rationalize this and then put this over a common denominator of 4a squared. In order to do that, you multiply the top and bottom by 4a. This then yields a quadratic like this, where you have x plus b divided by 2a all squared is equal to b squared minus 4ac divided by 4a squared. This should start to become a little bit more familiar. You can then square root both sides, and remember, when you square root a number you have a positive and a negative square root. 4 over 4a squared will just square root into 2a, and now if you rearrange to get x, you actually get minus b plus or minus the square root of b squared minus 4a divided by 2a. This is the quadratic formula. And that means you've actually just completed the square on any arbitrary equation and you've obtained yourself the quadratic formula. Interesting. So what have we got more to come? We've got a discriminant of the quadratic formula, and we are going to revisit simultaneous equations where one of them is a quadratic and the other one can either be a quadratic or a linear equation, and we'll proceed to try and solve those type of systems. We will definitely have a look at geometry, and the most important thing is having graphical representations of these equations that we're solving. At the end of the day, it's great that you can solve an equation that relates two variables together, but having a pictorial representation of them to find any visible relationships is much more of an important interpretation than just solving an equation. Next, we're also going to have a look at angles and shapes, along with trigonometry, which is just one of the most fundamental concepts in mathematics. It appears in more topics than we need it to, but that's because trigonometry is so widely used, and there are many properties within trigonometry that you'll learn about that will hopefully utilize later on in the videos. We'll then also have a look at calculus and derive calculus from first principles. What that is we're going to look at how you can draw tangents to these graphs that we're going to look at from geometry, and infinitesimal calculus allows us to derive equations for these tangents. So it's a form of differential calculus, as we call it. So if you like the content, please like and subscribe, or leave a comment down below if you have any questions regarding the derivation of the quadratic formula or applying completing the square methods in general that you've learned throughout this video. And please stay safe and peace out.